This is Udu Maths. Please don't forget to subscribe, like and share this channel. Today I want us to look at the topic angles of elevation and depression under trigonometry. Angles of elevation and depression under trigonometry. Okay, now when you say angle of elevation, what is an angle of elevation? An angle of elevation is the angle formed between the line of sight and the horizontal to the eye level. Horizontal line to the eye level. So let me make an illustration for you to see. So let's assume this is a building, and then there is a ball on this building, on the top of the building. Okay. Then there's a boy also here who wishes to play this ball here. Maybe somebody can help in bringing the ball down. So this is the building. Okay. Now, this is the eye, and this boy is looking at the ball with this line of sight. So we call this the line of sight. And then this line here is the horizontal line to the eye level. Let me draw it properly. So this is the horizontal line. So horizontal to the eye level. Okay. So the angle formed here is let me call it theta, is the angle of elevation. So angle of elevation. Angle of elevation. Okay. So I said it is the angle formed between the line of sight and then horizontal line to the eye level. The angle between is the angle of elevation. So look at it properly. The angle should be above the horizontal line to the eye. The angle should be above the horizontal line to the eye. If it's below, that one is also a different case. But this one is above the horizontal line. So we are making reference to the horizontal line to the eye level. Okay. Okay. Now when we talk of the angle of depression, the angle of depression is the angle below the horizontal line to the eye and the line of sight. So the angle below the horizontal line to the eye level, that is the angle of depression. So if let me come clear. When you talk of angle of depression is the angle formed between the line of sight and the horizontal line to the eye level. And this time the angle should be below the eye level, below the horizontal line to the eye level. Okay, now let's look at an illustration. So let's assume there is this tree here, and then a boy climbed the tree. So when the boy climbed the tree, there was this car also moving. So moving in, and then the boy is somewhere here, climbed to the tree. Okay, so the boy is looking at, this is the eye level, and then this is the car. The boy is looking at the car. So the angle formed here, let me call it alpha. That is the angle of depression. So this is the eye, horizontal line to the eye. So horizontal line to the eye. And then this is the line of sight. So line of sight. Okay, so the angle formed here is the angle of depression. So I said the angle of depression should be below the horizontal line to the eye. So the reference is still on the horizontal line. If it's below, that is angle of depression. If it's above, that is angle of elevation. So let's look at some examples and see how we can solve questions on this. Okay. Now let's look at this example. From a point 60 meters from the foot of a vertical pole along level ground, the angle of elevation of the top of the pole is 42 degrees. What is the length of the pole? Okay. Now we are told that from a foot of a vertical pole. So somebody is standing, and the distance between the person and the foot of the vertical pole is 60 meters. Okay, and then we are also told that the angle of elevation between the top of the pole and that person's eye level, or the eye, is 42 degrees. So we are told that we have to find the length of the pole. Now let's look at how we can resolve this example. Okay, so we need to draw this question. So this is the pole. So this is the foot of the pole, and then somebody is also standing here. So this is this is the eye of the person. So the line, let me draw a line from this point to join the top of the pole. Okay, and then the distance from the person to the foot of the pole is 60 meters, and then the angle formed here. So let me make this. So the angle formed here is 42 degrees. Okay, now let's find the distance between this place. Let me call it A, and then B. This place becomes C. Okay, so here we know of trigonometric ratios. So this is 42 degrees here, and we are told to find the distance BC, the height of the pole, and this is 60 meters. Now we have adjacent to the angle, then we want the opposite. So we can say that we can use tan, which is using opposite over adjacent. So tan 42 is equal to opposite, which is BC over adjacent, 60 meters. Okay, so tan 42 is equal to BC over 60 meters. Okay, so I can do cross multiplication. So BC becomes 60, that is this time, the 60 tan 42. Okay, so now let's put this on a calculator. So this on a calculator gives 54 meters. So it means the height of the pole. So therefore, the height of the pole is 54 meters. Okay, let's look at another example. Okay, let's look at one more example. A lighthouse tower is 35 meters above sea level. If the angle of depression of a boat from the top of the tower is 15 degrees, how far is the boat from the lighthouse? So let's draw this the diagram that corresponds to the question. Then we look at how we are going to solve it. The question, let's assume this is the level ground, and then this is the sea. Okay, so this is where the lighthouse tower is. So this is the lighthouse. Okay. So this is the lighthouse, and this is the boat. Okay, there are some people in the boats. Okay, there are some guys in the boats. Okay, now the angle of depression from the top of the tower to the boats is this. So that is, and this is, let's assume there's an eye here. So this is the horizontal to the eye level. So the angle of depression formed here, that is the 15 degrees. Okay, now we are told to find the distance between this point and then the boats. So how far is the boat from the lighthouse? So this is the lighthouse and this is the boat. we are told to find the distance between them. So I can draw this in a form of a triangle. Okay, so, and please, we should also know that the angle formed here is an alternate to this one. So if this is 15 degrees, the angle here is also 15 degrees. Okay, so I've redrawn this. Now, this is the angle, this is the line of, the horizontal line to the eye, and this is the line of sight. Okay, so this angle here is the same angle, that is alternate angles. Okay, now these two lines are parallel. So definitely the angle here should be equal to this one. Okay, now we are told to find the distance from this point to this point. And a lighthouse tower is 35 meters above sea level. So it means the sea level is this one. Now this is 35 meters. Okay, so using this one means we have the angle, this is opposite, and we are looking for the adjacent side to the angle. So we can still use the tan. Okay, we can still use the tan. Or we can even get, that one, just we need to find the distance here, this distance and then this one before. So just, we use the tan and it will be simple for us. Then what we have, tan 15 is equal to, that is opposite, which is 35 over adjacent, which is the distance AB. Okay, now we need to cross multiply and divide both sides by tan 15. So this and this becomes AB tan 15 equals 35 degrees, sorry, 35 meters. Okay, now we need to divide both sides by tan 15 since we want the distance AB. So tan 15 here, tan 15 here also. So the distance AB is going to be 35 over tan 15 degrees. Okay, and this one, the calculator will give us 130.6. So 130.62 meters. Okay, so the distance from the foot of from the lighthouse to the boat is 130.62 meters. Okay, so thanks for watching. We'll meet in the next class. The name has always been Odum Maths. Bye.